Okay, good morning, guys. Let us study some computer science today. Let's start with the AI for a moment. So, I wanna learn the basics of computer science. Like, what topics do we have? BTech. Yes. Let's see. That's great to hear. Learning the basics of computer science is a fantastic foundation. We got programming fundamentals like Python, C++, Java, and data structures and algorithms, computer architecture, operating systems, databases, software engineering, networking, web development, mathematics, artificial intelligence, and machine learning, cyber security. Okay, so let's start. Great, let's dive into the basics of computer science. Here is a brief overview of some essential topics for you to get started. So, programming fundamentals, syntax, variables, control structures, functions, and methods. Data structures, arrays and linked lists, stacks and queues, trees and graphs, sorting and searching algorithms. CPU, memory, input and output devices, operating systems like process management, memory management, file systems, structured query language, data modeling, development life cycle, design patterns and testing, protocols, TCP, IP, HTTP, FTP protocols, network topologies, okay. Web development, HTML, CSS and JavaScript, mathematics, discrete math, linear algebra, probability and statistics, okay, basic concepts and algorithms, cryptography and network security. Alright, let's study one topic in detail today for our academics. Fantastic, let's dive into data structures and algorithms. That's what I thought actually. So, it's a fundamental topic that will help you build efficient and optimized software solutions. It is an in-depth overview. We got arrays. Definition: a collection of elements each identified by an array index. Insertion, deletion, traversal, searching, and sorting. Storing a fixed size collection of elements. Arrays are used. Linked list: a sequence of elements where each element points to the next. Okay, single linked list, double linked list, circle linked list, insertion, deletion, travel, dynamic memory allocation, implementing stacks and queues. Stacks, a linear data structure that follows the last in first out LIFO principle. Queues, the first in first out principle. Okay, push, pop, peek, inquire, insert, okay, DQ, okay, NQ, insert DQ, remove front first element. Order processing, breadth first search, BFS and graph. Tree is a hierarchical structure with a root node and child node forming a tree. Binary search tree, binary trees, AVL trees, B trees. Okay, we got graphs, a collection of nodes connected by edges. Algorithms, bubble sort, selection sort, insertion sort, merge sort, quick sort. Linear search, binary search, depth first search, breadth first search. Dijkstra's algorithm, Kruskal's and Prim's algorithm. You have given a brief overview of the topics. Let's dive deep into each of these. Okay. Got this. Let us start writing the notes. I think we can copy this, right? Or we can write it even in the OneNote. I can copy that later. Okay. I'm going to type this instead of copy pasting because I will get what I'm typing. Element student contiguous memory locations. Each element is identified by an index starting from 0. Cool. And insertion. Adding an element to the end of an array. Deletion. Removing the last element. Traversal. Traversal. Accessing each element of the array sequencing. Is it going to stay like this or expand? Okay, it is expanding. Thank God. Okay, we can do this. And we have understood the basic terms like insertion, deletion, traversal, and let us see, searching, linear search, checking each element until the target is found, binary search, dividing the sorted array into halves to find the target. I have understood what linear search means. I have studied binary search before, but we will see that. I will see this binary search in detail. So we got methods like bubble sort, selection sort, insertion sort, merge sort, quick sort, etc. Okay, here is a code given to us. Let us perform this code. Since it is in Python, we can do that. Save file, new file, Python file. Okay, that's awesome. So first we are defining a variable named array, and the definition of array is different in Python compared to others. Generally we use the curly braces, but here we are doing it in a form of list or something, and we are appending. It is a method. So what is the value that we are appending? We are appending 60, and if we print array, we get, okay, I need to send this in the next snap. I will send it to project 1, Yeah, we got 60 added at the end of the list. Okay, cool. And we can insert a value at a specific index. Let us insert 15 between 10 and 20. So 10 has 0 index and 15 we need to get it in the 1 index. And what is the value? 15. So first we will say the index and the object, and then we can say print array. So we got 15 inserted between 10 and 20 because we told it to insert in the first index position. And we can directly remove the last element. We can say array.pop. Okay, this is a method, so I need to put this in classes. Okay, the last element was automatically removed, and we can remove something at specific index as well. Suppose we want to remove the 15 we have inserted. What is the index of 15? It is 1. So now the 15 will be removed as well. Okay, great. And traverse the array. Let's do this. For element, it's a variable we are defining here for element in array. Okay, print element. We are using a for loop, so it is going to print all the elements separately. Okay, that's awesome. And this traversing, and we are doing linear search here. We are defining a function called linear search. It is our own function. So the parameters are array and target. So these are the two parameters. So we are doing a linear search here for I in range, length, array. Okay. So we are iterating through every element and checking if the array. Okay, automatically it is going to start from 0, right? Okay, the array index is equals to target. Okay, why did I put a semicolon here? Okay, return I minus 1 because the index starts from 0, right? I think you can do this because he has written those two things separately. This should work. I can pass linear search for the array and the target. What is the target? We need to find 30. Let's see if it is going to run. Or you can write a print statement here. Array element found at what position? I minus 1 right position. I don't know if it is going to work, but let's see. Okay, invalid syntax. Yeah, I need to put a comma here. Okay, so array element 1 position. It is not supposed to be at 1 position, right, people? If I is equals to target, Then we can separately write an index. Index is equals to I minus 1. Or I think I plus 1, right? Because we are coming in the opposite direction. Like the index of this is 20, but the position is second position. So the syntax is correct, but you can separately write a variable and do it, but it will take a lot of memory. It's not the best practice. We can directly write I plus 1 here, but it improves the readability of the code. Okay, suppose, and we can also write a else block here. Else print element is not found, and suppose we will insert an element that was not present here. So let's see if the else block is running. Okay, so we don't want this to run like so many times, like inside the for loop. So else we can define another variable not found is equals to 1, and we can write another if conditional here. If not found is equals to 1, print element not found. It is not the best practice again, guys. It takes a lot of memory, but it is alright. Okay, I still put it in the for loop, and I'm going to cut this code and I'm going to put it outside the for loop. Okay, so we got the element not found thing. So we can remove this. And what is this problem? Okay, so element not found. We have successfully implemented the linear search. I'll put it this way, and I need a little explanation of the binary search. Okay, something went wrong. Hello, are you there? Hey, I need a little explanation of binary search. Okay, there is a lot of typos, but it understood. Binary search is an efficient algorithm for finding an element in a sorted array. It works by repeatedly dividing the array in half and comparing the target elements with the middle element of the array. Okay, left and right and middle. If the target is equal to the middle element, okay. Narrow down the search by setting right is equals to mid minus 1, okay, and left is equals to mid plus 1. Time complexity of O log n, much faster. Okay. So binary search is an efficient algorithm, it seems. So left and right is equals to 0. Initialization, left is set to 0, start of array, right is set to last index. I don't think it is set to length of array minus. No, there is something wrong with this code, that's what I'm saying. Because the explanation and the code are not syncing. Okay, this is... Okay, come on, okay. So we are writing a binary search function. Let's see. Def binary search, and the arguments are as common array and target. Okay, and left, we were told to left is equals to 0 and right is equals to len is a built-in function array minus 1. We set it to last index and this should work. So we are using an iteration here while left is less than or equals to right, because left is always smaller, right, because the right has larger value, and we are writing the mid is equals to okay left plus right. Why did we do the floor division? Because we don't want any floats here, that's why. We have defined the mid as well, if array and passing the mid. Okay, it's mid is equals to target right. We can directly say um, I think we can directly print it, right? Print mid. Great, and I am writing an else block here. What happened here actually? It should be coming to this place, is it not? Yeah. Okay, else array mid is less than target. What does it? No. It messed with the indentation somehow. What happened with this indentation? Why did it get an indent here? Yeah. See, one indentation can cause a lot of errors. If array mid is equals to target, if the condition is true, we are printing mid, or you can print target obviously. Now, right, you need to print the position, not the element. Okay, print mid and bro. Eating me. Why am I getting spaces? Okay, elif array mid is less than target. So the array element is less. This thing works for only sorted arrays, right? Wait, does the binary search only work for sorted arrays? Okay, it only works for sorted arrays. Now that's sorted, so it is lesser. That means it should be on the left position, right? Because we sorted the array in the ascending order, so we are shifting the left from 0 to this one, and else we are shifting. Okay, I have give it a space again and it is going to mess with the code. Right is equals to, and we are shifting the right to a lesser value, mid minus 1. And why is it returning minus 1? Okay, index. Where did we use this index thing? If index is not equal to -1, element found at okay, we used an string, I got it, but okay, I need an explanation of this bubble stop. No, this is what is this? Yeah, binary search. Too many times. So I need an explanation of this binary search. Why are we returning -1 and we did not define the variable index before, so how is it going to know? Those are the doubts that I'm having. Okay, binary search function stores its alien variable like index. Did we write that? We didn't explicitly define index within the function, but we do assign the function's output to index when we call it. So write the complete code to print the element and the output. Thank you. Okay, we are writing the same code. Again, this person is using this. Okay, index, we are storing it in the index. So we can write the same code here. Return mid. What do you say? Okay, so we have already our array, and so index is equal to binary search array, and what is our target? 40, let's say. If index is not equal to -1, okay, if nothing works, we have given -1, right? Because that is like to know if the code has run or not run, I think. This explanation more. If index is not equal to -1, okay, print the element is found at what position? Index, let's say. Else print element not found and the array. This should be working. Okay, I am assigning it to that, right? Oh, we have systematically like written. Okay, element found at position 3, 40 is at position 3. So I have confused with this line of code before this. Left comma right. So they say simultaneously, right? Left comma right is equals to the 0 comma. So that means left is equals to 0. That doesn't mean right is equals to 0. I thought he assigned right to 0. Okay, should be working. That's great. So what have we learned today? We have learned arrays and some common methods of arrays like appending, inserting, popping, and popping a specific index. And we have performed linear search. Right. We have performed linear search and we have performed binary search as well. I have understood the logic actually of these two. Thank you guys.